Welcome to AminAcademy.com. In physics, let us discuss about Earth's satellites. Earth satellites, also called artificial satellite, artificial object launched into a temporary or permanent orbit around Earth. Spacecraft of this type may be either crewed or uncrewed, the latter being most common. That means most of the satellites are uncrewed, unmanned satellites. The idea of an artificial satellite in orbital flight was first suggested by Sir Isaac Newton in his book Philosophia Naturalis Principia Mathematica in 1687. He pointed out that a cannonball shot at a sufficient velocity from the top of a mountain in a direction parallel to a horizon would go all the way around the earth before falling. Although the object would tend to fall towards Earth's surface because of gravitational force, its momentum would cause it to descend along the curved path. Greater the velocity would put it into stable orbit like that of the moon, or direct it away from Earth together. That means greater velocity would put into a stable orbit like that of the moon. That means moon is always around the earth in elliptic orbit or direct it way away from earth altogether. The moon is earth's only natural satellite. It is the fifth largest satellite in the solar system and the largest and most massive relative to its parent planet, with a diameter about one quarter of that of the Earth. Now let us do some example problem regarding satellite launching as time period, everything. Look at this example. A satellite revolves around a planet of a mean density of 10 power 4 kg per meter cube. Mean density is 10 power 4 kg per meter cube. If the radius of its orbit is only slightly greater than the radius of the planet, find the time of revolution of the satellite. Take G equal 6.61 into 10 raised to minus 11. Look at this given thing. The density of material of planet rho equal 10 power 4 kg per meter cube. G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. To find the period of satellite, here we have to find period of satellite means how much time it takes to revolve around one revolution around the planet. Look at here. The time period of a satellite orbiting around the Earth is given by the formula T equal 2 pi square root of R plus H whole cube by Gm. If satellite orbiting a very close to the Earth, that is H is very less to R, that radius of the Earth, then H can be neglected. That means in this formula, we have to use R over Gm, square root of R cube over Gml, because H is considered very less compared to R. Now, we know that the density is mass per volume, that is mv by v. Therefore, from that we can calculate mass equal to rho into v. Rho into 4 by 3 pi r cube is the volume of sphere. Now, substituting this in the equation before that equation, here we will get T equal to 2 pi square root of r cube over g rho into 4 by 3 pi r cube. And for the simplification, it gives 2 pi into 3 g rho into 4 pi. This r cube and r cube cut. Therefore, time period equal to square root of 3 pi over g rho. Now we will substitute the values. 3 into pi is 3.14 over g is 6.67 into 10 raised to minus 11 into rho equal to 10 power 4. After calculation by using calculator, you can get it time period is 1.044 hours. One more example. What would be the speed of a satellite revolving in a circular orbit close to the Earth's surface? Given g equals 6.67 into 10 raised to minus 11, density of the Earth is 5,500 kg per meter cube, and the radius of the Earth is 6,400 kilometer, and also find its period. Now, density of the matter is rho equal to 5,500 kg per meter cube is given. Radius of the R is 6,400 kilometer, that is we converted to meter is into 10 power 6.4 into 10 power 6 meter. G is given. Now to find the orbital velocity. Here, if satellite is orbiting very close to the Earth, that is h is lesser and lesser to r, then h can be neglected. Therefore, r only, r plus h is r only. Therefore, velocity of the satellite equal square root of gm by r. Now density is rho, we know that mass per volume. From that we are getting mass equal to rho into volume, density into 4 by 3 pi r cube. Now substituting this values Vc equal g rho 4 by 3 pi r cube by r, and g rho 4 by 3 pi r square, r cube and r is cut as r square. Therefore 2r square taken out the square root, that is 2r g rho pi by 3. Now we are using the values Vc equal to 2 into 6.4 into 10 raised to 6 square root of 6.67 into 10 raised to minus 11, that is g value. Here rho is 5,500 into 3.14 over 3. After simplifying, we will get Vc, that is Vc equal to 7.931 into 10 raised to 3 meter per second. That is velocity you can write is in terms of kilometer, that is 7.931 kilometer per second. Also you can find the time period of a satellite orbiting around the Earth is given by, here time period is 2 pi r, full round circumference, divided by velocity is the time period, that is 2 into 3.142 pi, that is r equals 6,400 divided by Vc, we got 7.931, we'll get 5,771 seconds. So divided by 360, you can get it in terms of hours, 3,600, that is 1.408 hours. Therefore time, so it take 1.408 hours to complete revolution. Next question. Here the mean angular velocity of the Earth around the Sun is 1 degree per day. The distance from the Sun to the Earth is 1.5 into 10 raised to 8 kilometer. The distance from the Sun to the Earth is 1.5 into 10 raised to 8 kilometer. Now given angular frequency omega equal to 1 degree per day, radius of the orbit is r equal to 1.5 into 10 power 8 kilometer, that is we can convert 1.5 into 10 raised to 11 meter, because multiply by 10 power 3, then g is given, then you get the solution. Omega equal to 1 degree per day, then we are converting radians is pi by 180 into divided by 24 into 60 into 60, that is radian per second. This omega angular velocity calculate. Now t equal 2 pi by omega formula, that is 2 pi and omega, right, and two pi by omega, you calculate that time. From the time period we get this 2 into 24 into 60 into 60 into 180 seconds. Now we know that time period equal to 2 pi by square root of r cube by gm, the formula. Squaring both sides, we get t square equal to 4 pi square, in square root will vanish, and from that we get calculate mass equal to 4 pi square r cube divided by gt square. Put the values here. we get mass equal to 2.062 into 10 raised to 30 kg. The mass of the sun is this much. One more example. If the moon revolves around the earth once in 27 days and 7 hours in an orbit with 60 times the earth's radius. That means moon revolves around the earth with a distance of 60 times the earth's radius. Find g at the earth's surface. R equal to radius of the earth is 6400 kilometer. Given that radius of the earth given, that is 6.4 into 10 power 6 meter, radius of the orbit of the moon, r equal to 60 times the radius of the earth, that is 60 r. Period of the revolution of moon is 27 days 7 hours, that is 27 into 24 into 60 plus 6 into 60 plus 7 into 60 into 60, because 7 hours also converted as a seconds. This is this much seconds. That means after that you have to find gravity at the earth's surface. Then t equal 2 pi, time period is 2 pi root of r cube by gm. That is t equal to 2 pi r cube by r squared gm. R squared g, because gm is, can convert r squared g. Then squaring both sides, t square equal 4 pi squared, square root 1 is r cube by r squared by g, r squared into g. Then from that g take out, t squared go down, we have g is 4 pi squared r cube by r squared t square. Then we are substituting this r is 60 times the radius of the earth, that is radius of rotation is 60 times the radius of the earth, that is 60 r whole cube. Then expanding this and get 4 pi squared 60 cube into r by t square. We are substituting the values 4 into 3.14 squared 60 cube into radius of the earth by r squared into 60 into 60 square t square. Then we get exactly 9.81 meter per second. Next question. Assume that moon describes a circular orbit of radius r about the earth in 27 days and that Titan describes a circular orbit of radius 3.2 times r about Saturn in 16 days. Compare the mass of the Saturn and the earth. Comparison they can get easily. Look at this one. Tm, time period of moon, is given 27 days and radius of the orbit of the moon is rm equal to r, let it be r. Time period of the Titan is tt equals 16 days. Radius of the orbit of the Titan is rt equal to 3.2 radius r. Then time period formula is t equal to 2 pi root of r cube by gm. Then t square, squaring both sides, we get from that m, we get 4 pi squared r cube by gt square. Same for Saturn and Earth, we are comparing m Saturn by m Earth is mass, this mass, both comparing. The common factors cut, then we can get it r Titan by r moon whole cube equal to into tm by tt whole square. Then from that relation is this. That means you are substituting the values, we get 93.3. That means ratio of the mass of the Saturn to the Earth is 93.3 ratio 1. That is, mass of the Saturn is 93.3 times greater than the mass of the Earth. So far we have done more problems about Earth satellite, natural and artificial. Also we do the problems, time period and mass, everything will form. We have done. Please subscribe our YouTube channel.